Hello, everyone, and welcome to today's Safety and Health webcast, FR and the Elements, Mother Nature versus Flame-Resistant and Arc-Rated Clothing, sponsored by Bulwark. This is Alan Ferguson, Associate Editor at Safety and Health Magazine. I'm monitoring today's learning opportunity. Thank you for joining us. And before we start this presentation, I have to go over some preliminary items. As a disclaimer, the views of today's speaker and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise, product, or publication does not mean the Council or magazine endorses those items. Next, I want to let you know that at the end of today's webcast, we will conduct a question and answer session. To ask a question, simply type it in the text box in the lower left-hand corner of your screen and click the button for Submit Question. Feel free to ask your question any time during this presentation. You don't have to wait for the Q&A to begin. Now, we'll try to answer as many questions as possible, but we might not have time to get to every question. The good news is that any unanswered questions will be forwarded to today's speaker. At the end of the webcast, you'll be asked to complete a brief evaluation survey. I'll let you know more about that after this presentation. This webcast is archived, so you can access it after today's live event. To listen to this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. Finally, if you need basic troubleshooting information, click the Help button located on your screen. With that, let's go ahead and get started. Our speaker today is Derek Saying, Technical Training Manager at Bulwark. Derek has worked in the FR clothing industry in a variety of roles for more than 20 years. He has also conducted more than 250 educational seminars on the hazards of arc flash and flash fire and has developed more than 40 hours of training for Bulwark University, covering all aspects of FR clothing. On average, he has led 20 live FR, AR training sessions per year in multiple countries. Along with being a recognized subject matter expert, Derek is also a qualified safety sales professional, certified EHS professional, and certified EHS technician. Derek, whenever you're ready, go ahead and take it away.
Alan, thank you very much for that kind introduction. And good morning and or good afternoon, whether you're listening to us live or archived today. Certainly appreciating you taking the time out of your valuable resource to spend it with us here. As Alan had a disclaimer, guess what? So do we. So let's get the attorneys out of the way. Presentation is for informational purposes only. Customers of Bulwark Protective Brands are solely responsible for conducting their own hazard risk assessment to identify safety hazards in their work environment. Customers of Bulwark Protective Brands are solely responsible for selecting appropriate garments and protective gear for their employees and ensuring wearers use the garments and protective gear properly and in conjunction with the appropriate gloves and footwear. Because working conditions and other factors may vary, Bulwark Protective Apparel does not make any representation that these garments and protective gear will protect wearers from injury. So on to the good stuff. Why are we here today? So when we're out in the field and when we're talking to our end user community, the folks that actually put these shirts, pants, and coveralls on their back to protect them against short duration thermal events, under the terms of flame-resistant arc-rated clothing, one of the things we always get asked about, what do we do in the extremes? When we're talking about the extremes here, we're talking about heat of the summer and cool of the winter, or cold of the winter, depending where you are. For example, where I reside here in Arizona, winter's over. We get a short reprieve here for about the next, 60 to 90 days, and then we start going into the hundreds. For other parts of the nation here, you guys are still in the freezer, so there's going to be different hazards associated with that. So we'll talk about a little bit, a very, very basic understanding of what heat stress and cold stress is, what your flame-resistant arc-rated clothing, how that plays a factor in your decision-making process, some best practices in those conditions, and what should you look for when selecting flame-resistant arc-rated clothing for the extremes. So we, like a lot of industries, have tons of acronyms, and I apologize because after 20 plus years, I kind of use them without, in many cases, telling you what they are. So a few brief definitions. A fire retardant, that's a chemical additive that suppresses fire by interrupting the fire flow, the fire tetrahedron. You see fire retardant chemistry with FR cotton natural fibers and fabrics. You see fire retardant chemistry going into acrylics, like a modified acrylic, aka you have non-FR mode acrylics and FR mode acrylics, so fire retardant chemistry goes in there. Flame resistant is the end result of all that engineering. These are, by definition, garments that will self-extinguish. They will not support combustion. They will not melt and add to the injury. Arc rated is we take the basics of flame resistance and we do additional testing, additional development for it to withstand that short duration thermal exposure in an electric arc. So we, in our community, we utilize FR-AR. Why? It's FR first, and then it becomes AR, so we use flame-resistant arc-rated. Heat and cold stress that we're talking about today is the general name for several medical conditions, and we'll touch on that briefly. And you'll also hear me talk about at the end of this, OSHA, we're all familiar with, and then NIOSH, that is the National Institute for Occupational Safety and Health. That basically is where all the research that's done to help support OSHA, and that's also in the DOL. So on to the meat and potatoes. We work in hazardous environments, and what happens when that hazardous environment gets invaded by Mother Nature, and now Mother Nature is the hazard. So we have an arc flash hazard because we're an electrical utility worker outside, or we're a general industry electrician who happens to be out in the elements, or we're in a refinery, or we're on an oil and gas rig, and not only do we have our thermal hazard for flash fire, which we're protecting against, now Mother Nature's intervened and also added extreme heat and or extreme cold. So who's at risk of environmental stress? Well, that's kind of basic. Anybody and everybody who's out in the elements. Think of line crews, drilling crews, heck, the people maintaining the vegetation in and around those areas, snow cleanup crews, sanitation workers, and first responders. Anybody and everybody who is out in the elements. So we always think about heat stress gets a lot of attention. So what is heat stress? What leads to heat stress? And as we said, it's a general name for a number of conditions. And they escalate as you go up. You look at a heat rash, heat cramps, heat exhaustion, and then ultimately leading to heat stroke, which if and when it does occur can be fatal. And it's a graduated scale, but you can accelerate through the precursors relatively easily. So why is that? Number one and foremost is hydration, hydration, hydration. Your lack of fluid is what leads to these accelerating conditions of heat stress, ultimately all the way to heat stroke. We can protect against that by being hydrated, increasing the amount of rest that we have. While we rest in shade away from that direct source of that heat, that big fireball in the sky. And we can also make sure that we're in pretty darn good shape to be working in the extremes. Whether it's extreme heat or extreme cold, from a physiological standpoint, it's going to accelerate any deficiencies that we have that we bring to bear. If we are slightly overweight, if we don't have a good cardiovascular system, if we have breathing issues, any weakness in our physical being, in our physiology under extreme heat and cold is only going to be accelerated and further manifest its way into what we're doing. For example, just losing as little as 3% of our fluid. And these studies primarily are done with athletics, so they can see performance dropping dramatically. We can see that in our occupational athletes. When you're under stress, and we're talking about environmental stress here, productivity and your abilities to react and do all the things you need to do your job can be hampered. I live in the dry heat. My folks in South Texas and in Florida, you all live in the wet heat. Both are just as equally strenuous and equally difficult to tell. Well, in dry heat, you actually can stop sweating, which in your head you can misread your environment, misread your physiology because, hey, I'm okay, I'm not sweating or anything, I'm still perfectly dry, things must be good. In a humid environment, you are so moist you can't differentiate between what's the environmental moisture condition and what am I actually contributing to it. So as you go through the workday and you use observational evaluation, both dry and wet heat can be misleading into how your body's reacting. That being said, there are common factors that we'll keep coming back to that can contribute to heat stress. First and foremost, your age. Okay, just like anything else, the better we get, the more experience we get, the more we do something. Okay, the older we get, the more experienced we get, our abilities to withstand stressors in the environment tend to get reduced. We may think we're 25, we may feel that we're still 25, but if we are 50, your body's going to react like it's 50. Fitness levels, again, anything that you can do to bring better mechanism, better physiology to the work environment is going to help you, because as you sweat, as you process, whether you're trying to stay warm with your metabolic rate in the cold environment or you're trying to lose heat in a warm environment, you're going to do it more efficiently the better health level and fitness level that you have. As we talked about, how much of you is insulative? That's our nice, polite way of saying made up of fat cells. Fat is an insulator, so it's either going to hold heat, which you don't want in a hot environment, or in a cold environment, it's going to be beneficial. So we want to have a balance there. Obviously, what we consume is important. Alcohol, caffeine, all these are diuretics. All these are going to impede your performance, even many, many hours after taking them, because that stressor, that environment, is accelerating anything that is negative. Any medications, make sure we have thorough discussions and we are communicating with our medical team any significant change, because they all have that long list of side effects that we listen to every time one of these commercials comes on TV. It can affect how you perform in an environmental stressor like heat, and extreme cold. Your diet, make sure it's balanced. Then we get into dehydration, environment, activity level. Notice that we're not even talking about clothing yet, and we're already 10 deep when we talk about environmental stressors. So there's a lot of things to take into place that most of us don't even think about. So as I said, types of heat-related illness. Heat-related illness and severity of that illness is driven by fluid loss. The more you lose, the more you accelerate into a difficult situation. Heat rash and stuff, most of us see if we've ever worked outside for any extended period of time. Areas to where moisture will accumulate, we'll start to see small rashes. As we continue to work, we might get some cramping in our fingers, cramping in the arch of our foot, cramping in our calves. Because we're moving and working around, that's your body telling you it's running out of stuff that keeps those muscles from cramping up. Electrolytes, fluids. And then as we move now, we're going into heat stroke to where we can't control our temperature at all. Worst case scenario is we look over at our colleague and they've stopped sweating. They're starting to get pale. We're starting to see their inability to cool down. All those things start coming into play where we're accelerating to worst case scenario, and that's where heat stroke and disability come in. Our response to this, and what we need to train our people on anytime you're dealing with a hazard, is as that severity increases, as it escalates, we need to have a metered response. As we first talked about heat rashes, maybe a little bit of cramping, those are relatively easy. Stop working, get in the shade, start hydrating. Hydrating with cool water to begin with, and better yet, cool water that has a little bit of electrolytes in it. There's a lot of good products on the marketplace today. Make sure that we're not doing anything. Carbonation's not great for you. Obviously, non-alcoholic, that's a no-brainer. As it goes up further, now we're talking about if we're in isolated areas. Do we have an igloo cooler on the back of the truck? Do we have ice in that igloo cooler? Do we have the ability to make ice bags and start getting them in the armpits, the back of the neck, in the groin area? Then what's our 911 response? Because once we're into that precursor to heat stroke, we are definitely in a 911 situation, and we need to get people cooled down and into, more importantly, a medical facility. Our body can do a lot of this work on its own if we properly supply it. There are 4 basic ways that we cool down. Radiation. Heat is radiated through the skin and absorbed by the cooler air. Remember, we're always going from hot to cold, so we're trying to get that heat off of our body. This is where fabric and what that fabric fiber complex is made up of can either hinder this process or it can help accelerate it. Conduction, direct contact with cool subjects. That's like taking that ice-cold bottle of water, holding it to our forehead, taking those ice-cold bottles of water, placing them under our armpits, placing them in and around our core. That is conduction. That'll help cool us down. Convection, moving air. What kind of it? Again, now we're getting into that fiber fabric complex. What kind of open weave? What kind of structure does that fabric have to where it allows air to pass easily, or does it restrict air from moving through? Because if we can get some air permeability in there, that's going to help cool us down. And then really the last piece and the biggest piece is the evaporative cooling. That's what we all understand as our ability to sweat, our ability to move heat from our body, from our core that's heating up and getting it through sweat into the environment and hence attempt to cool us down. The challenge is when the ambient air temperature gets over our body temperature. And what's that? Typically, it's 98.7 degrees. When your heat index or your ambient air temperature gets into triple digits, you are well above your body's core temperature. So all those mechanisms that we talked about are gone. There's only one mechanism left, and that's your ability to sweat. That is fluid driven. That is a fluid balance. That's also an electrolyte balance. That's where once we get into those ambient air temperatures, whether our heat index tells us that's what it is or the actual thermometer is the real temperature, we need to be able to sweat. And once we run out of that capability, bad things start happening. So how can fabrics, before we even start about flame resistant, how can fabrics assist in cooling? Asterisk to this slide. This is all in balance. If these are just one element in and of itself is not going to be enough. For example, I can make a lightweight garment, okay? But if that's all it is, it doesn't have an open weave, it doesn't have good air permeability, it's made with fibers that don't absorb and move moisture, then is it going to be ultimately assisting in me cooling down? Not necessarily. So we want to have a good combination of the three when we're evaluating fabrics for cooling. So that's one indicator. And if you think about high-end performance fabrics today, yes, they are relatively lightweight. Yes, we can move air through them relatively easy. And three, they have some pretty cool science with them now to where these hydrophilic and hydrophobic fibers work in combination to get moisture off my body, assist in that sweat mechanism, and hence assist in cooling me. Now, where we get the tweak is when we first now have to be protective. Remember, when we're talking non-FR, we just have to work on that comfort zone. We have to work, just make it lightweight, open. Now, if we're adding protection, meaning I have to have some substance to protect you against short-duration thermal events like arc flashes and flash fires, protection supersedes everything. But in order to be comfortable in a hot environment, perform in a hot environment, I need to have all three of these mechanisms working in balance in some way, shape, or form. So, for example, let's say I need to have a heavier fabric in order to protect you. So lightweight, then I need to make up the balance by, let's make it open weave, so I've got air permeability, and let's make sure we have the latest and greatest science and we have moisture wicking built into the fibers so it's not a finish, so it doesn't wear out in 25 launderings. Let's make sure it's built into the fiber matrix. Let's make sure that we have good open weave so that we balance that additional weight that we bring to bear to protect against a 10,000 degree arc flash shooting 1900 degree molten copper at me at 750 miles an hour. So we want to always have that balance as we get into the protection phase. So what do we recommend for workers in the heat? Make sure to protect exposed skin from direct and indirect heat. That's a fancy way of saying, you know what, short sleeves may intuitively, or you may think are going to be more comfortable, be better in hot environment, but exposing that skin we've known for a long time to that big orange fireball in the sky, you actually get better by covering it up and reducing that radiant load. So we want to make sure long sleeve, lightweight, all your additional gear, boots, gloves, etc. Make sure there's some lightweight properties to it. Take that load off. Head protection should be appropriate. Get shades in there for our utility guys. When we build our shades for our hard hats, when we take our hard hats with the wide brims, make sure that those shades have some FR properties, that they will self-extinguish, not melt, drip, add to the injury, etc. In cool locations during work breaks, limit the amount of time that you're outside during these heavy loads of heat. My APS, SRP, and TEP guys here in Arizona, you don't see them in buckets at noon unless it's absolutely emergency conditions. They're managing their work hours in the morning. They're managing their workouts into the evening. Even though it's still 105 degrees out, when that sun starts to go towards the horizon and that direct radiation is not there, it's actually tolerable and you're able to get work done. Transferring into the other side of the coin, so what is heat stress? Just like cold stress, what is cold stress? Just like heat stress, it's a general name for several medical conditions. It's when the body is unable to warm itself, we can get hypothermia, frostbite, chilblains, trench foot as byproducts of those. It's a measurable condition, as is heat stress. It's actually several cold-induced illnesses that we talked about. What's the primary? Lack of warmth. This is clothing. This is your insulator. Wind can dramatically change something. Even in 50 degrees ambient air temperature with a light rain, and all of a sudden I get a cool wind whipping up off the lake, that can take something that would seem it's not going to be inducive of cold stress, can become cold stress because I get wet, the wind is blowing, I don't have my proper gear with me, and now I'm starting to get cold. I might even start shivering. My teeth might start chattering. Those are all indicators that cold stress is occurring. And as with heat stress, poor health, poor hydration, lack of rest breaks in warm areas are only going to accelerate those things. So what's happening in cold stress? Well, your metabolism, your body, again, is trying to stay where? At 98.7 degrees. Where before it was shedding heat, Now that furnace, that metabolic rate, is starting to accelerate to try and stay warm. The caloric output in cold environments is almost twice as much as it is in regular everyday walking around at 75 degrees. The caloric consumption needed to stay at that core temperature can be 2 to 3 times what the normal intake is, because that furnace is working on high. In hot environments, the body, as I said, needs to release heat. We want to lessen the amount of clothing that we have to a certain degree. We want to lower our activity levels to a certain degree, and we want to be able to sweat. In cold environments, it's almost the inverse. We want to pile clothing on us because that's the insulative component. We want each of those layers to be specialized because we're occupational athletes that need to conduct ourselves. We're not just trying to get down the street. We're actually trying to do something during a day. We need to increase that insulation, and we may want to also, as we begin to sweat, decrease that activity level, because the last thing we want to do in cold environments is actually have our workload and our insulation be out of balance so that we actually start sweating, because that will ultimately make ourselves colder, and we will accelerate the cold stress. How cold is too cold? Just like how hot is too hot. If you're acclimated, it can be very different than if you're unacclimated. Take any extreme environment and take the people who live in that environment on a day-to-day, year-to-year basis. If it's February in Minot, North Dakota, and it's minus, pick a number, and I live there year-round, yeah, it's going to be cold, but I'm going to be a lot more acclimated to that versus someone like myself who relocates from Arizona and walks into that temperature completely different. Take the inverse. Take someone who comes from a colder region, bring them to my desert in July, and try to get them to, or make them work outside for an 8-hour workday. That is not going to go very well. So acclimation to these extremes is key. In fact, most of the studies today will tell you that acclimation to extreme temperatures is the strongest predictor of success if we do that incrementally. 2 hours, 4 hours, 6 hours, working our way up to that 8-hour workday or 10-hour workday, whatever you have, taking into account all the other balances that we have in there, working in the extremes, that's going to be more beneficial than just dropping someone in and expecting them to be able to work. So as we said, how does your body react to cold conditions? Over time, your body is looking to shift its blood flow to the important parts. That is your core, your heart, your lungs, your liver, your kidneys. That is where all the heat and all the blood is going to flow to, because your body's going into survival mode. What does that do? That takes blood flow away from fingers, toes, arms, legs, and over time, in a relatively short period of time, you will lose functionality in those areas because your body has just gone into survival mode. Even losing as little as about 3.5 degrees will put you in a hypothermic state, which ultimately, as in heat stroke, can lead to fatality. Environmental factors, as they change over time, does not take a lot to put you into stress. As temperature drops, as wind increase, as humidity, precipitation, light snow, heavy snow, drizzle, rain, freezing rains, in time is going to equal stress. The body is going to be working harder and harder to maintain that core temperature. And those freezing conditions combined with inadequate clothing or inadequate ability to heat up is ultimately what's going to drive things from bad to worse. So what's the challenge in the cold? When the ambient temperature is well below your body temperature, insulation from clothing is absolutely necessary and vital. How healthy you are, how fit you are, is going to determine how you perspire while you're working, because we don't want to overheat and we don't want to perspire. When clothing becomes wet, we're now adding to that potential stressor. And then also we got to remember is once our workload is reduced, as we're finishing, coming to the end of the day, we've got to be able to be conscious and manage that. Think of starting at the day early in the morning. I've got a jacket, I've got a sweatshirt, I've got in between those, I've got a fleece. So as we work through the day, as the temperature rises, and that temperature will be relative, it goes from -20 to -5. My workload is increasing. I've got to be able to doff those layers because I want to stay neutral. I don't want to be working so hard and be so insulated that I sweat, and I don't want to be so uninsulated that I start to get cold. So as we're working through the day from a clothing standpoint, we have to manage our insulation and our workload. Because just like in heat, our body heat is lost through conduction. The cold is outside and I'm warm, and my heat is going to travel from hot to cold, and the barrier in there is what I'm wearing. It's going to be whatever my base layer is, my work shirt, my fleece, my outer layer that also has some water repellence or water resistance because it's withstanding light snow, possible rain, freezing rain, sleet, etc. So there's going to be a barrier component there. Well, if I'm working to such a point that that radiant heat can't get outside, it's going to cause me to sweat. I don't want that. So I'm going to doff those outer layers. And in a non-FR environment, that's completely fine. There's very little thought process that goes into what's the protection of the next layer, and what's the protection of the layer after that, and so in a non-FR, a non-thermal hazard world of arc flash and flash fire, we're just dealing with the insulative components to preventing heat stress. So as we look to prevent, cold stress, as we look to prevent cold stress, know what the symptoms are. Monitor your physical conditions. Dress properly for the cold. Stay dry in the cold. Keep extra clothing. Why? If you get wet, if you sweat, let's have something to change into. Here we want to have warm, sweet liquids. Why? Remember that caloric output we're putting in there, that metabolic raise that we're getting in the cold? We want to have some calories when we're rehydrating. We want to have those electrolytes in there when we're rehydrating. And then obviously look to have some place where we can also rest and we can warm up, whether that's the cab of the truck with the heater on, or it's heating huts, out of the elements. We've got some place to stay warm. So layering in cold environments provides better insulation. That outer layer that we talked about against wind and precipitation, that middle layer of wool or fleece, etc., and then an inner layer of synthetics that help keep the moisture wear off of your body. You want it to have great moisture vapor transfers. You want it to be absorbent and be able to move that any moisture that you're creating away from you. Obviously, hats and hoods to reduce the amount of heat coming off your head, balaclavas, all those things, insulated gloves, waterproof boots, everything in here that we're talking about is going to have that insulative component. The acronym COLD is great. Cover. Don't overexert. Dress in layers. And with all possibilities, stay as dry as you can. Equip yourself to beat the cold. Base layers, balaclavas, skull caps, watch caps, mid layers of fleece or wool, smart wool shirts and socks, pocket warmers, insulative gloves. Those all sound great. Now, here's the challenge. Everything that we've talked about here in a non-thermal hazard, relatively easy to do. The training on this, very common sense. If you've grown up in that environment, you have been doing these things since you were able to walk and you were first tobogganing down the slopes back in the day. The challenge now becomes when we go into the environment's a hazard, and now we're still dealing with our short duration thermal hazards of arc flash and flash fire, because everything that we talked about here has to have a flame resistant arc rated component. Employers have to recognize that we have a heat hazard and a cold hazard, plus they've also recognized that we're outfitting you with flame resistant arc rated clothing because we have thermal hazards. So as employers are going through their hazard risk assessment, they're looking to include information and training for risk prevention, what kind of symptoms to look for, be your brother and sister's keeper, the importance of monitoring yourself and your coworkers, what treatments are available short term, in the immediate term, and then where we're calling for additional medical assistance, and then how does PPE factor in to all of the above. Employers can take following steps. I mean, we can start looking at administrative controls in that hierarchy of safety. Schedule maintenance and repair jobs when temperatures are not as severe. Schedule jobs for cooler or warmer parts of the day depending on what the environmental stressor is. Reduce the physical demands of the workers. Have more people there to do what would take to get some of that load off. Use relief workers. Assign extra workers. All these things sound common sense, and there may be resistance just from stating the fact we need more people to do the same job when things get extreme. Provide warm and cool areas during breaks. Get out of the heat, get into shade, better yet, get into cool. Get out of the cold, get into heat, do what you can, and then monitor for the symptoms as you go forward. Avoid exposure to extreme hot and cold. When hot and cold environments or temperatures can't be avoided because of emergency situations, make sure you know what to do to protect yourself. Clothing, layering, whether it's hot or cold, layering can be beneficial. Loose clothing, air is an insulator. All right, loose clothing also helps in that convection, the moving of hot to cold. Purposefully designed clothing designed with your movement in mind and beneficial for both the environment. Because why? Everything that we're hearing about, whether it's the American Meteorological Society, NASA, all the top agencies are telling us what? Extremes are only going to be getting worse. Exposure to heat on average kills about 800 U.S. workers a year. Hypothermia and extreme cold conditions, about 1,600 people are affected every year. Of those, about 23%, okay, or approximately, I don't know, what's that, roughly 400 workers a year, are so almost 1,200 succumb to the extremes in temperature, both in the hot and the cold. So what resources are available out there for us to look at and utilize? As I said, NIOSH does a lot of the research in and for OSHA, and even though we only are seeing guidelines coming from OSHA, there are some states out there, California, Washington, Minnesota, and others are coming on a regular basis who are putting in regulations in and around both heat stress and cold stress. Both of them respond similarly, both NIOSH instructing OSHA and OSHA stating it to us. Whenever possible, wear loose-fitting, light-colored clothing for heat, loose-fitting for good airflow and movement of sweat. Notice that they say light, not lightweight. That's light in color for heat stress. Obviously, khaki versus a navy, you're going to have you're minimizing or looking to reduce the absorption and that fabric holding heat. Weight is in and of itself as a single factor is in breathable single layer garments is scientifically not a factor. a 7-ounce cotton work shirt, a 7-ounce FR cotton work shirt, a 7-ounce 8812, a 7-ounce, 5.5, they're all going to, as far as physically and physiologically, have the same effect on us as the wearer as anything. So in and of itself, FR and non-FR is not a contributor to being towards heat stress. If you go to OSHA and go to the website, they've got some really good resources for you to utilize in protecting your workers from heat stress. Water, rest, and shade that is the go-to. WRS, that is what OSHA has been preaching for years. Simplifying, understanding the heat index and what the risk levels are and what you should do for protective measures. They walk you through that. So get on OSHA.gov, use the resources that are available. They walk you through the difference between heat exhaustion or as it leads to heat stroke. When one becomes manageable and one of them becomes an emergency, train your people on that. Similar resources when we go into cold as a stressor. In fact, the American Conference of Government Industrial Hygienists, the ACGIH, has a great graph there on the warm-up schedule of 4-hour shifts, and they actually single it out when you look at wind, 5, 10, 15, 20-mile-an-hour winds, and how the temperature varies to where only emergency work should be utilized. Basically, unless it is life-altering, stop work. And it gives you some clear guidelines to help you walk through that. So there are great resources out there that we can utilize. So in the last couple of minutes here, this is kind of like the payoff to where, man, FR guy's been talking now for 40 minutes, and he hasn't really talked a whole lot about FR clothing and what I need to bring to bear with my teams who are exposed to arc flash and flash fire hazards. So first and foremost, and I alluded to it earlier, heat stress and FR clothing. Be very, very cautious of marketing terms. Lightweight and comfortable are subjective in the sense that comfort is completely subjective. If you don't believe me, next time y'all have a team meeting, take a look around the room. Look at the faces that are looking back at you and look how they're dressed. You'll have a hoodie over top of a t-shirt. You'll have t-shirt only. You'll have polo only. You'll have polo and lightweight jacket. You'll have every variety of single layer clothing that you can wear in that room, and I would argue the reason they're wearing it is because they're comfortable. So the point is fabric weight, fabric style, fabric thickness, fabric anything has very, very little to do with anything. So be very cautious of marketing terms, aka I market it as lightweight, aka you're going to be more comfortable. How are you measuring that? It's subjective. You can't measure it. Yes, you can measure moisture vapor transfer. Yes, you can measure air permeability. Yes, you can actually get the weight of that garment. Understand all three of those have to factor in a balanced equation to ultimately give you something that's going to assist in a hot environment. One characteristic in and of himself is not enough. Single layer FR clothing does not trap heat or restrict heat removal in any other regular non-FR clothing. Heat is shed primarily by evaporation when you're over 98.7. Can it assist in moving moisture from your body? If it's fully synthetic, can it deter from moving moisture from your body? Yes, all those things can factor into it. But the simple fact of that garment's single layer breathability is a contributor, whether it's long sleeve or short sleeve. Actually, long sleeve arguably is more protective. So bottom line is, whatever you consider, get in touch with your provider, look at the latest measurable conditions of any garment that they're professing, and then the last and most important thing, get it on your people's back. Wear test, wear test, wear test. And if you have a hot environment that you're, wear it in the hot environment. Don't test a single layer new shirt in January when you're looking to implement that in July, and vice versa for cold stress. We're looking at threshold limiting values here in what's called a clothing correction. And the reason I share this is work clothes, long sleeve and pants, and cloth, woven materials, and coveralls. There is no adjustment when it comes to the wet bulb globe correction factor, meaning there you are, right there. There's no correction needed if you're wearing single layer work clothing as far as contributing to or more or less to heat stress. Now, when we get into double layer clothing, when we get into barriers, when we get into walking into chem suits, chemical barriers, anything along those lines, yes, you can see the correction factor absolutely goes up, as will anybody tell you. If I have to climb into an arc flash suit to do my job, yes, I need to monitor myself, because in hot environments, I'm going to have about 10 or 15 minutes of work in that layered system. If I'm working in a refinery and I'm outside and there's a chem release and I'm in my flame-resistant, chem-resistant Ty-Chem coverall, yes, I am going to have a certain amount of time to do my job versus just wearing my single-layer coverall and or shirt or pant. Why? Because fabric works in a single layer to help keep you hot and cold. It's an insulative barrier. It removes perspiration, so in cold environments, it keeps you warm. And in hot environments, it's actually assisting the body's natural cooling mechanism, which is sweat. So when FR clothing is also your PPE, remember, we're in that cold environment. I talked to you about base layers. Work layer, our wool and or our fleece layer, and then our outer layer, which has some water-resistant capabilities. So what happens in my workday as the environment gets hotter, my workload's increasing, and I want to doff these layers? You have to, and this is key, make sure whatever layer you are dressing down to, whichever layer you're taking off, that next layer has to be equal to or greater than the hazard that you're in. If you're in a flash fire hazard, every single layer has to be NFPA 2112. If you're in an arc flash hazard, you need to know what the incident energy is, and every subsequent layer that you are dressing down to that final layer that you're working in has to be equal to or greater than the incident energy you're facing. So it is key, as you are factoring in Mother Nature as a hazard and my existing thermal hazards, that whatever layer, outer layer is exposed to that, as all your standards tell you, have to be equal to or greater than the hazard that it's exposed to. That's a huge challenge, because we're managing all those capabilities that we talked about in order to be efficient in an environmental stressor, plus we have to balance that with everything else that we're seeing. So how do we find the balance? Believe it or not, today we are at a junction in time where FR is beginning to mirror our other performance fabrics. We are looking at the occupational athlete the same way we're looking at the recreational athlete and the professional athlete, and we're bringing a lot of that discovery to bear and making sure that first and foremost it has FR properties. What are those FR properties? It puts itself out, does not melt, drip, and add to the injury. And if we're going to put it in an arc flash, we do additional testing to show that it will insulate you up into those hazards. So bottom line, hydration, respirate, shade, cover, all those things are control methods. Make sure we're implementing those. Schedule your heavy work during the warmer, cooler parts of the day. Have them rest in warming or cooling tents, depending on the environment. Dress in layers, both in the hot and the cold. 2 lightweight layers in the heat with moisture wicking capabilities can be cooler than 1 heavier layer, and plus you get the additional benefit in that arc flash hazard and additional protection in our flash fire hazards. Protect against the wind, get out of damp and wet clothing, acclimate your people, and if have a strong acclimation program, that's definitely going to be beneficial. And from an FR protection standpoint, make sure you're consulting with proven subject matter experts that can help evaluate shoes so we don't miss something when we're layering and we're adding more variables to it. And then lastly, wear trial, wear trial, wear trial. any of the top folks today will be more than happy to walk you through a very measured and guided wear trial so that you get the best out of your investment. So with that, I'm going to turn it back to Alan. And like Alan said earlier, if we don't get to all your questions in the next 10 minutes or so, the good folks at NSC further those on to me. And if I don't have the answer, I'll definitely find some resources for you and get back to you. So with that, again, I thank everybody for taking time. And hopefully, as with all of these, in 45 minutes, we can't touch everything, but hopefully you all got a nugget that you can take back. Thank you for your time.
All right, thank you so much, Derek, for your expertise and insightful presentation. Before we start the Q&A, I want to remind everyone of the evaluation survey we're asking you to complete. The survey should be appearing on your screen now. Your input is important because it'll help us improve our future webcasts. If you do not see the evaluation survey on your screen, please turn off your pop-up blocker. You may also access the survey by clicking the survey button near the lower right part of your screen. Okay, now let's get to some questions. Our first question, can you discuss arc-rated and FR rainwear? What standards are applicable, and does the raincoat need to be equal or greater than the arc flash hazard if my base layer is equal or greater than the arc flash hazard?
Great question, and there's a couple of questions within that question, so let me do my best to get through them. And Alan, if I miss a piece, please refresh my memory. So first and foremost, for arc flash, ASTM 1891 is the standard that you want to see in that label, in that gear. You'll also see an arc rating. That arc rating will be in calories per centimeter squared. It might be 24 calories per centimeter squared. That's your arc rating. That'll be usually an ATPV. It may be in some gear, maybe an E sub BT. Both of those are arc ratings by ASTM. 1891 means it's been tested in an arc. What you have to be extremely cautious of is rain gear that is marketed as flame resistant and it's not. Not that it may or may not self-extinguish, it may or may not work because it's only been tested to one standard, and that standard is not a performance standard. That standard will be typically ASTM 6413. It'll have, and it's been coined to be self-extinguishing. Why? When you hold a strip of that laminate over top of a vertical flame, because 6413 is a vertical flame test, that will actually recede from the heat. You won't have a char length. You won't have any noticeable flame to self-extinguish, and they'll get it to pass and market it as FR. 99.999%, if you were to take that same raincoat in an arc flash, it will fail miserably. It'll either evaporate and be gone, hence no protection, or it will ignite and continue to burn, and you'll have a big hunk of burning plastic sitting on your perfectly good arc-rated shirt, pant, and coverall underneath, totally nullifying your whole program and what you intended to do. So, recap. Look at the label. It'll have an arc rating, and it'll be ASTM 1891. The next piece, if you're in utilities, OSHA tells you the outermost layer has to be equal to or greater than a reasonable estimate of the instant energy you're up against. There's your answer. Yes, your rain gear, if you're on a 10-calorie piece of equipment and that's what your reasonable estimate of the incident energy has been communicated to you, your rain gear has to be at least equal to or greater that in a single layer by itself, regardless of what you're wearing underneath. Why is that? Well, heck, we can have rain in the south in July where it's 80 degrees out and it's still pouring rain. So what if they put their rain gear on, but they've already doffed their work shirt, so they have a cotton T-shirt. So in that case, my rain gear now is acting not only as a shirt, but it's my primary protection. It's the only protection that I've got. But as long as it's equal to or greater than the hazard I'm exposed to, perfectly able to do that.
Okay, our next question. When OSHA references an arc-rated hood or face shield with a balaclava, would an arc-rated sweatshirt with the hood up or a hoodie be considered compliant?
So I'm going to, I don't like doing this, but for sake of this, I'm going to make an assumption. When we're talking a hard hat, balaclava, arc-rated face shield, all that stuff, we're looking at a 70E application potentially, or we might be a utility application when we're outside looking at a meter or something at ground level. That all being said, how that interface is supposed to work is hard hat, balaclava, face shield, safety glasses, hearing protection, that's what we're utilizing. Taking the hood from my, I'm going to assume it's a flame-resistant arc-rated hoodie, I'm going to put that on my head in lieu of a balaclava is not what the intent is. I'm going to put my hard hat over top of that hoodie, and I'm going to utilize it as I would a balaclava. Not the intent. Why? That balaclava is built specifically to have some neck protection. It's built specifically to interface with that hard hat. Hoodies come in a variety of thicknesses. We could have that hard hat when we're adjusting the harness, we can have it not fit correctly. There's a whole bunch of things that come into play to where really we are, as my dad used to say, we're jerry-rigging something to work like it should and not designed to work that way. So the recommendation is that best practice is not to use a hoodie underneath and have a hard hat over top of it. As we would throwing a hoodie over the outside of that, I don't know where you're getting into some peripheral vision impairment. We're not able to see all the way around. I would discourage that from a best practice standpoint also. I mean, hoodies in general, people like them. A lot of places disallow them because they're hang-up hazards. You can get caught on places. A lot of places don't know if that flame-resistant arc-rated properties are extended to the hoodie. The hoodie's now the outermost layer. It has to be equal to or greater than the hazard. There's just a lot of complexities when we bring hoodies into the workplace where we have thermal hazards, so just be cautious of that.
Our next question, does there any FR clothing that provides UV protection?
Not that I'm aware of.
Is there, and for our next question, is there a global list of certification agencies for flash protection fabrics?
Global agencies.
I'd have global to do list of certification.
Yeah. I'd have to do a little bit of research. They're not on the tip of my tongue. Primarily what we find is NFPA 2112 compliant garments are utilized both North America and in many places worldwide. They look to that, in our case, there's different third-party certifiers. U.L. is the most popular here in the United States. That's where they are independently certifying that shirt, pant, and or coverall is meeting 2112 requirements. So it's certified by the third party to be NFPA 2112 compliant. That's your flash fire hazard. That's the most universally recognized one that I've seen. Europe's going to be the big differentiator from that. The Middle East, you find a lot of what's adopted in the Middle East comes from NFPA. You see a lot of North American companies that have taken the standards over there that are being utilized, as with the European standards in that kind of mixing spot there for petrochem industry. You see both. But for North America, it's primarily you're looking to NFPA 2112, which is building garments for a short duration thermal event such as flash fires, pool fires, etc. And it gives you a very, very strong criteria, and then a third party comes back and verifies that all those steps have been met, and you're good to go. So I can definitely look for that question as it comes back to me, and if I can find any additional resources for a global approach to that, I'll definitely forward those along.
Well, thank you again, Derek, and thank you, everyone. Unfortunately, we have run out of time. I'm sorry we didn't get to everyone's questions, but all of today's unanswered questions will be forwarded to our speaker. Once again, I hope you take the time to fill out the evaluation survey on the screen to give us your feedback. That ends today's Safety and Health Magazine webcast. I'd like to thank Derek Sang, everyone at Bulwark, and, of course, all of our listeners. Have a safe day.